Covalent compounds are different than ionic compounds in that they share electrons instead of giving or taking electrons. So if we have a compound such as carbon dioxide, carbon has 4 valence electrons because it's in group 4. And oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So actually let's rewrite the carbon so this will work out better, visually speaking. It has 1, 2, 3, 4 electrons. Oxygen has 6 valence electrons. So what's going to happen is the carbon and the oxygen are going to share enough electrons so that they can each have a full valence shell. So now if you look at it again, oxygen has 2, 4, 6, 8 electrons. This oxygen on the left has 2, 4, 6, 8 electrons. The carbon has 2, 4, 6, 8 electrons. So everything has a full shell of 8 electrons. I know I made that kind of messy. But another example would be silicon tetrachloride. Just like carbon, silicon has 4 valence electrons. 1, 2, 3, 4. And chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. And there's 4 chlorines, so we've got to draw all of them. 1, 2, 3, 4, 5, 6, 7. Whoops. 1, 2, 3, 4, 5, 6, 7. And one more up here. 1, 2, 3, 4, 5, 6, 7. So silicon and carbon are going to share electrons, and what this means is that now silicon has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. Each carbon, oops, I miswrote that one. Each chlorine, has 8 valence electrons now because it's got 2, 4, 6, 8 valence electrons. 2, 4, 6, 8 valence electrons. If I were to rewrite this so you could see what's happening, you would see that silicon tetrachloride would be Si with all of these chlorines, and the valence electrons are constantly rotating around each of the elements that's here, and they're going so fast that because they're being shared, each element essentially has 8 electrons in its outer shell at all times.